Hello and namaste. Welcome to the Academia. Hello, my dear friends. I'm very happy and delighted that you all are watching my videos, and it is giving me strength to publish at least one video every day. And thank you for your efforts and your precious time so that I can share my knowledge. And I'm sharing my knowledge not because I know everything. I'm sharing my knowledge to know that if any one of you know better than this, so that you can suggest in the comment box and I will apply those suggestions in my real life. And because my theme of my life is progressive, I always wanted to be a progressive person, and I always keep learning and keep advancing in my life. uh, Apart from that, this channel is dedicated for those who are interested to grow their career and to learn new things. Although Katia and Ansys are even Python is are not the new things for the society. These all are existing mode, just uh, you know the from 60s and 80s. Okay, before we born and our parents. Uh, I hope m- and even my parents would be in their school. Okay, so these softwares are very old, but the new thing is their advancements. Okay, every time we face challenges in our product, so we look for a solution, and to overcome those challenges, we create something innovative to solve our real-time issues. And for that, we have these type of softwares like Katia, Ansys, Unigraphics, Pro-E, Autodesk Inventor. Uh, I also use CloudCAD of Onshape and SimScale. So um, someday I will show you my real time work. And also today, this video is dedicated and to the one of my project which I got in some years back. Okay, this was academic writing, and one of the client was looking for a case study which was related for a L shape steel, structural steel, and there was some calculations. I have this written data, as you can see. Let me show you something. It is mirroring. Okay, you will see in the problem. So today we are going to know more about Ansys. Know more about Ansys. Okay, so we will learn very new things. So let's start. I hope you can see the screen. Okay, so in previous video, I started from a point and I headed you all in a different direction. So apology for that. Okay, so in this left section, you can see that there is a design assessment where you can assess your design. There is a electric which in which you can uh, evaluate your electrical equipments and their load and their other capacities. There is a explic dynamics and fluid flow. Okay, similarly, the most used thing we use in CFD is fluid flow fluent and fluid flow CFX. Also, we use polyflow, and the most common thing are static structural analysis and the Where is the IC engine? This is the IC engine. You will uh, find many jobs on the job portals. If you are a user of Fever or somewhere else like Guru, you are um, if you want to get projects, live projects, you can earn every day at least 10 to 15,000 every day. Uh, if you want, if you are expert and capable enough, then 15,000 is a lowest average. You can go beyond that. Okay. So let's discuss a case study. A case study says that they have a L section of certain dimension, and I I I show you how we can solve that. And to that, we just move to the static structural, and I will discuss few things in a static structure design so that it you will be able to understand the you know let's rename it. That is like, so after clicking here you can rename it like I'm writing new uh, new data or new. Okay, data is good. Okay, new data, so this will be saved in as a new data. Okay, so we have few things on a toolbar. You can see here there is a static structural, which is a operation we are going to perform, and we have this engineering data. So let's discuss a few things about this engineering data, what this engineering data is. When you click on it, there is an Ansys workbench. Okay, you can go over here and you will learn more thing, but right now you just simply double click here, and you can see here that we have this structural steel, and the property of this structural steel is that we have um, its density like 7,850 kg per meter cube. Okay, this is the unit. So you can find every property of this related to this structural steel. Even you can find its tensile yield strength, you can find its compressive yield strength, tensile ultimate strength. Okay, and using these data you can find multiple things like it's a isotropic instantaneous coefficient. If you want to check, you can go with this data, and you can calculate its linear elastic property. Not only the elastic also, but you can find its plastic property. Suppose that we have one bilinear isotropic. So when you just simply drag it here somewhere. Okay, so we have this, and suppose that you are putting its value like 200. It's not okay. So in a tabular, you will get the value. Okay, and also you can see here there is a bilinear isotropic hardening. So what bilinear is? Uh, this is not at, suppose that at 30 degrees centigrade, yield strength you have is like uh, zero point 0.2, and this is also in MPa. Suppose that 240, and at in second condition. So this is a bilinear condition. Okay, so in this bilinear, let me show you one thing. uh, with the help of this whiteboard. This is your stress strain diagram. Okay, when you apply a force on a steel, and when it like deform from a place like this from here. So this is the first direction, and this is the second direction. So now you can understand why we call it bilinear. If there is a two different values, okay, sorry, two different directions. Similarly, if you want to go with the multilinear, so for that, when you apply a force at a certain temperature pressure condition, and it like goes like this, okay, or this is it. So this failure you will see is called engineering failure, and when it tends to like this is a real failure. You must be aware of this. Okay, so what happened, man? Can you see the screen? Okay, so in the bilinear case, you can clearly see that there is a force applied which is yield strength of 2 megapascal, or it. Okay, so recording is in progress. Let me share my screen. Sorry, it was some network issue. And now, similarly, you can see that if you will click with like this point 0.02 or point 0.2, let's go with this. And again, click it with point 0.4 and make it like uh, 245. Make it like 250. Okay, so it should appear here.